fills the space goes seeking any resonant partner. If there are multiple partners, they will receive energy, they'll share it. So here's a schematic of what's here. We have this function generator, which is the general radio unit oscillator that was designed probably in the 30s when Tesla was strong. It's driving the primary wound one way. The secondary goes to the elevated capacity. The same on the receiver. And there's a bridge rectifier, and the fan is out here as R1. So, and we have a single conductor connecting to. So obviously, the energy is flowing through the space. At the time of James Clerk Maxwell and Faraday, they knew there was an ether. They said it's inconceivable that, I mean, if the energy leaves here and arrives there, it must have been somewhere in the interim. It had to be in something that had mass. So there was no doubt in 1865 that there was an ether. No doubt right up until the Michelson-Morley experiment. Well, my colleague, Mo, he was fascinated by this picture of Tesla with the spiral antenna and winding of wire of a different color on the outside, on the periphery, which is not what Mao did. Miles is on the underside and it's inside. So the ones that Mo and I have wound are in this pattern. We wind the primary first, a single conductor thick, and then we wind a second, our primary around it. And Tesla said that the primary and secondary windings must be loosely coupled. He made that very clear in the patent. Well, when we build transformers, we look for the closest possible coupling. Leakage flux is our enemy. We minimize leakage flux. So the intent here is that the secondary will exactly slave the primary, right? They share the same flux. And that's not the goal here. Here we have the opposite goal. So a loose coupling is perhaps like the contact between your hand and a child on a swing. Right? It's loose. You're not following the swing. You're contacting briefly. Now we have a Faraday cage here, a garbage pail. I can tell you what happened. We put a radio in it. When the radio goes silent, we know there's no electromagnetic waves penetrating the Faraday cage. This is surprising because if I do that, it's not a Faraday shield. The serrations here allow waves to get in. It's surprising how hard it is to make a cage. But if we put the fan and the receiver inside here, they run as if, well, they run the same. So there is no dissipation of the wave in the wall of the Faraday cage. What does that mean? It means that it's not a transverse wave. We say electric, magnetic, they could go like that, but there's no projection in the direction of travel. That's a transverse wave. So when it hits a metal surface, it gets shorted out. The energy of the electric and magnetic wave is dissipated in heat in the Faraday shield surface. If we have a longitudinal wave, where there is a projection of field, either electric or magnetic, in the direction of propagation, well, then there's nothing to short on the walls of the shield. The shield isn't a shield. Now, physics doesn't recognize scalar waves. If you search it on Google, you'll find that it's, what do they say, hypothetical fringe science. And even Wikipedia has gets hired, it's scaled to wave page. We thought there might have been, but now we know there isn't, so we're going to take down the page. But here it is. These are longitudinal waves. So the transmitter can hear the receiver. Radiation waves don't do that, right? When you transmit from a radio transmitter, you have no expectation of hearing anything back from your subscribers, from the listeners. And the transmitter can couple to multiple receivers. Any number of tuned circuits tuned to the same frequency in the space will share the energy from the transmitter. So in fact, if energy goes missing, you say, well, I have to go and find the resonant circuit that's sucking my energy. Energy is delivered to each resonant receiver coil according to the load that's connected to it. And the receivers can hear other receivers. In other words, it's like a party line, like a piece of wire. It's like a piece of wire. And Tesla made comments like that in his patents, right? Not only did he say that inductance is measured in centimeters, he said it's well known that air is a good conductor of electricity. Not. 3 million volts per meter. Please. A good conductor of electricity. Well, here, air is a good conductor of electricity, isn't it? But you have to wind a spiral antenna. And it's not easy. And you might wonder, do you need these elevated balls? Well, I mean, the effect is there without them, which makes it much easier to build devices. You don't have the cube rolling. I've got a wonderful piece of copper. I got $50 worth of copper here. And inside is a neodymium. Wow. It's pretty slow compared to free fall. So what's happening? Eddy currents, Faraday's induction. I mean, when the magnet moves, it creates an electric field which causes an opposing magnetic field, and it takes that long for the magnet inside to draw. So, I know you want to get on to vector calculus. So here we go. Look out for heresy. Tesla ridiculed Einstein. You're wrong, Mr. Einstein. Ether does exist, as Sid Deutsch says. Tesla said, I think that material bodies do not gravitate towards each other, between each other, but it is the ether that makes one material body press to another. You might think that I'm being pushed to the Earth because that's drag. Right? There's maybe neutrinos, maybe energetic particles headed for the Earth and I'm in the way. So maybe that's the nature of gravitation. Tesla wasn't happy with action at a distance. We've all grown up with action at a distance, haven't we? Mysterious. There's no cause, there's no medium through which to carry the waves, the emanation, the energy. The energy exists at the transmitter. It doesn't exist. It doesn't exist in any medium until it gets to the receiver. So here's a cartoon. Need some levity here. Divergence of the electric field is charge density divided by epsilon naught. Divergence of the magnetic field is, however, 0, meaning that there are no magnetic monopoles. Divergence is non-zero in the presence of a field source. Plus positive divergence is like a hose. Well, it's like a tap with no hose attached to it. It's like an ethereal hose. And negative divergence is a drain. So we can have, you know, if you get up out of a chair, if the triboelectric effect causes your body to be electrified, you've got positive or negative charges on, and then you have divergence. You didn't until you got out of the chair, but now you do. Curl of the electric field is minus the rate of change of magnetic field, while curl of the magnetic field is mu naught times the current density, plus the all-important displacement current term, which gives rise to propagation of light. So what do you think of this idea as a comment? Dude says, it's a bit formulaic. So Professor John David Jackson, by the way, he was born in 1925 in London. My father was born in 1925. So, won't be related, I don't know.
150 years ago, Maxwell wrote 4 differential equations that unified electricity, magnetism, and light. The first equation expresses the view that there are no magnetic charges in the world. The second equation, discovered by Faraday, shows that a time-varying magnetic field produces a circuital electric field or an electromotive force. The third equation is Coulomb's law, which expresses the electric field in terms of its sources, the electric charge. The fourth equation, due to Ampere and Maxwell, shows that the magnetic field is related to its sources, the electric current, and a time-varying electric field. Together, these 4 equations describe everything in our electromagnetic world, from light bulbs and radio to iPods and X-rays.
Almost everything. Not this. Heaviside's contribution after Maxwell's untimely death. He died in 48, so Maxwell had a lot more. He wasn't finished his life's work by any means. Maxwell codified Faraday's work. Faraday was a superb experimentalist. So Heaviside says, well, this really distills down to 4 equations and 2 variables, electric and magnetic field. Well, that helped a lot, didn't it? So the book that I like is Skilling, 1942, Ampere, Faraday, Gauss B and Gauss D. Gauss B is actually the law that doesn't have a name. Gauss never promoted it, I guess. So in effect, we've got the effect on the left side and the cause on the right. So there's Ampere, right? We've got J, current causing curl of the magnetic field. And this is Maxwell's innovation, saying that there is a displacement current. And this is Faraday. And here's the statement that there are no magnetic monopoles. D of B is 0. And divergence of the electric field is charge. Charge. So when you get up out of the chair, you're creating electric divergence. So Ampere has 2 causal terms, while Faraday has only 1 causal term. There isn't a term added out here. So it's an asymmetric universe. Right? It's funny that God did that. It's kind of tilting over like this. Right? So what Mile has done simply is added a missing term here. He calls it B. And it's minus V div B. V is velocity, B is the magnetic field, divergence of the magnetic field. We heard Professor Jackson say the divergence of the magnetic field is 0. He said it was the opinion that the divergence of the magnetic field is 0.